see what we remember from AB about all that stuff. Speed, velocity, acceleration, all that fun stuff. What do you remember? So from AB, so if I have position as S of t, if I take the what? So the derivative, I would get velocity, good. And the second derivative is acceleration. Okay, what about speed? And you guys are on a roll. So speed is the absolute value of velocity. Okay. When is speed increasing? No.
When there's acceleration is a number.
No. What signs? Okay, so when velocity and acceleration have the same sign, then you're speeding up, right? Otherwise, you are slowing down. Okay, I need a volunteer to come up here. All right, thanks. Okay, all right. So let's think about this. So face that way. And let's say that his velocity is going that way, and his acceleration is negative. What's going to happen? It's going to slow down. Sorry, okay, so now let's say that his velocity is that way and his acceleration is increasing. What's going to happen? Speeding up. Okay, does that make sense? So that's like, hopefully you remember that. You have to have the same sign going on. All right, so we're going to be dealing with some of these things now, but with parametric and vectors. Okay? So here we could have our position vector. And you can do i's and j's if you like. I like to do it in component form. So here we can just have our x of t, y of t for the position vector. So to get to the velocity vector, what would I have to do? Very, very basic. Take the derivative. X prime of t, y prime of t. There's your velocity vector. What's your acceleration vector? X double prime of t, y double prime of t. Right? It's that easy. Don't try to make it any more complicated. So speed now, if we kind of think of that vector, speed is going to be your ds dt, if you kind of want to think about what's going on here. But all it is the what? What is that? I have x prime of t squared, y prime of t squared. Well, the arc length has the integral, right? This is we did a lot of it yesterday. The distance or the magnitude. So now, speed when we were here was the absolute value of velocity. Now we have speed is the magnitude of velocity. Okay? So all you're doing is the magnitude, which we worked on. Then we talked about acceleration and all of that. Slope of acceleration is just the component over the component. You're not going to also do like the whole dx dt like you did with the slope of the particle. This is slope like of acceleration. That's different. Okay? Probably will never ever have that though. All right, magnitude of acceleration. All you're doing is the magnitude of those components. Is that all right? Josh? Sure? All right. So we're going to do this example and kind of like see if we get all of that. You really already have all the basics. We're just now using velocity, acceleration, position. So a particle moves according to these equations. A wants you to find a single equation in x and y for the path of the particle and sketch the curve. We've already done this. What would you do here? Now we're not going to go to polar. We want to make it into rectangular, basically. What's the equation in terms of x and y? Okay, we could solve for t, but that would be really gross. In this case, that's not a good idea. So Sarah, what'd you say? Yeah, so we know that cosine squared plus sine squared is what? 1. So go solve for cosine, square it. Go solve for sine, square it, and you'll have your equation. And I want you to sketch it. What kind of curve is this? Ellipse. Good. And anytime you're dealing with parametric, what do you have to show? Direction. So Josh, at time equals 0, what point are you at? Let's see the 0. Plug it in here and here. Try again. 3 zeros. So that's when t is 0. What's the next t you want to try? We'll go and increase you. Well, 1 would be kind of gross. So pi over 2. So let's plug in pi over 2, and what are we? So which way are we moving? That way. So there's part A. Let's review. Okay, so B now says find the velocity and acceleration vectors at any time t, and then show that the vector A is equal to negative vector r. And vector r is just your position vector here. So let's go find those vectors. Well, what's vector r? Katie? What are you thinking? It's just the position. What component goes here? Huh? So what is that? Yeah. Yeah. So I'm going to keep going with you, Katie. What would be velocity? Good. And what did you do there? So then go ahead and find your acceleration. So when I find my acceleration, and if I pulled out a negative, that's just negative position. Questions about that? All right. So now it says, hey, find R, B, and A vectors when you have time of pi over 6 and time of pi. So basically, we're just going to plug in pi over 6 for what value? T. And now, instead of having sines and cosines, you're actually going to get numerical values because you're replacing the t's, right? So get those numerical values. ij vectors, if you like that better, go for it. I like component form. I think it's faster and easier. And if you have R, you can fill in A really, really easily, right? Because we just proved that A is negative R. I'll let you check and see how you do.
I'm good. Relax.
So you're just waiting for me now, and see if you can look at D. See how you might want to start that. Alright, did everybody get C okay? That would have been cool if I would have said A okay. But okay, anyway. So now we want to find the speed and the magnitude of its acceleration at each instance in C. Well, speed in general is what? Not the absolute value in this case. The magnitude of the velocity vector, which would be what in general? Square root of velocity vector is this guy, right? So it would be this first component squared plus that component squared. So we have 9 sine squared t plus 4 cosine squared t. Yes? An acceleration vector in general, or sorry, the magnitude of acceleration in general would be what? So that'd be 9 cosine squared t plus 4 sine squared t, right? Okay, but this wants it for each instance in C. So instead of taking those guys and squaring them, I'm just going to take the numbers, because we've already done that part. So I'm going to take that squared plus that squared and square root. There's your speed at time pi over 6. Okay? Let's see if you can get that. So the speed at pi over 6, so about right there, is radical 31 over 2. That's how fast the particles travel. And what about at pi? Oh, yeah, I was looking at the wrong one. Thank you. Thanks, guys. Erase stuff. So that would be -3/2 squared. I was just saying if you were paying attention. I just wanted to teach you.
Fair enough.
Yeah. This it's my
So rapid.
yeah. Because I like to look at me. Oh, I don't know actually. Is it? No, that's for acceleration. Sorry. Oh, I was looking at the acceleration one. All right, there you go. That's why you just don't write what I write. Lesson learned. All right. So then at pi, what's the speed at pi? So yeah. Which is bigger, pi over 6 or the speed at pi over 6 or the speed at pi? Yeah, so I mean that's definitely bigger than 16, right? So it's going to be bigger than 2. Agreed? So at pi over 6 we are moving faster than when we are at pi. Okay. So let's find the magnitude of its acceleration at those. Is that called anything? The magnitude of velocity? I don't know if it's called anything else. Sorry, Katie. I'm going to get rid of my position code. So. Alright, so the magnitude of the acceleration evaluated at pi over 6 would be radical 31 over 2 is what I got. See if you get that. You did or did not? Okay. And then the acceleration magnitude at pi would be 3. Does anybody want the formula written out? Okay. So, when is speed a maximum? We have speed going on right here, correct? So where is speed a maximum? What do we do? So we could find the first derivative of speed. Set it equal to 0, then what? Hit our critical points. Endpoints would be included. Do we have endpoints? No. So we have find our critical points. Set up a number line with all your critical points going on, right? If it goes positive to negative, it's a max. If it goes negative to positive, it is a min. And then I could say what those values were. Or I could do something a lot easier here. Okay? Or. So all that's great. And if that's what you've got to do, it will work. Alright? So here's the or. We can take speed and think, what t could I put in to get the very smallest value out? What t could I put in to get the very biggest value out? Right? So before I do that, I'm going to simplify this a little bit. So we said we had 9 sine squared t. Well, I don't want sines and cosines going on. I don't want to have to think about both the max and mins and putting them together. So what can I put in for cosine squared? 1 minus sine squared. And that would be what? Okay, 5 2? What about at 3 pi over 2? It's negative 1, but it is squared. So 3 pi over 2, etc., right? So I know speed is at max right there and right there. What about the min? 0, pi, etc., right? So the mins would be here and here. There you go. Not easier? You don't have to what? No, because you just use logic of like knowing your sine function of what would give you the biggest and smallest output when you square them. Okay? Now if it was just sine, it'd be a little bit harder, possibly. And I don't want to do the last one. So we're going to take your quiz, yeah, and then you'll still have a lot of time to work today.
What's my homework?